Okay. So you have a Kubernetes now deployment architecture. Deployment is like how you are managing it, or how you are installing it, or how you are maintaining it and configuring that. That's the part of the deployment. Okay. That's how you will be doing that. Okay. So in the deployment, you have your master node here. So either we keep it as one, or you can have a additional nodes. Okay, this I have not yet covered it. So you can create one more node, so that in the options of master node, one more node can be able to take that control. It is like a HA, like high availability. Okay. So that also we can do that configuration, but I don't want to take that time here for configuring. So that's why I am skipping that part to configure it. Okay. So now you can see you have control plane. So where there is a control manager, everything you are managing, all it is connected to worker nodes here. Okay. So in the worker nodes you have, this is not working. Okay. You have your container runtime. So we will be using the container D here. Okay. So we are not using any Docker here. We will be using the container D only. Okay. And then on the on top of this runtime, you will be running your pods here. So where you will be running your application inside this pod. Okay. So now at the physical end or at the cloud end, you will be running it these physical servers on your on premises. Okay. And if you don't want to manage it, so you will be running it on the virtual machines completely. You will be leveraging the existing virtual machine infrastructure, vSphere infrastructure. So where you will be managing the entire Kubernetes here infrastructure, or you will go with the cloud here. Either we will use AWS, Azure, or GCP. Okay. So you don't want to manage your infrastructure, you will go with the cloud here. So or else you will be picking up the bare metal here. So you will take lease of these infrastructure in cloud. So that is how you will be doing a deployment here. Okay. So now the connectivity, how the connectivity flows. So you will be having the external users who will be connecting to that particular app. Okay. And then from there they will be accessing that particular internet here. Through internet they will be accessing, or internally also they will access. So first you will be hitting the load balancer layer here. So what this edge layer will do, it will be distributing the load across all those servers which are able to take that particular input here. So it will be like you are getting at a time you are getting 1000 connections. Let's say you have 3 load balancers. Like you will be getting 330, 330 and 340. Okay. Equally you are distributing it. Okay. So then you will have a ingress layer. Okay, where it will be taking all that web traffic here. Okay. So from web traffic you will be going inside these either worker node or else you will be going through management tools. If you want to manage it, then you will go with the management area, or else you will be accessing the direct application or your API server. That is how the management, the external connectivity will flow here. Okay. So this part all will be hidden with the user here. So user will not be able to know how he is connecting, how internally it is configured. Okay. So you will just see how it is being projected here. Okay. So you will have all these infrastructure. So you have kubelet, kubeproxy and CNI plugin. So this you got to know now. In each worker node you will have this, so that you will get internal communication, internal network, and then commands from the API server. So these are all the requirement, and you have runtime to execute the pods here. Okay. So now you want to manage the cluster services here. Okay. So cluster services, where you will be managing all the related with the cluster here. So you want to manage the cluster. So where you have multiple services or multiple nodes, you will be managing with that. So I don't want to go into cluster services. So we'll see that one more deployment strategies. So in the document, where is the document here? Deployment strategies. Okay. So I want to deploy now strategies. Okay. So here by default, we will be having a rolling update. So rolling update is like gradually you will be replacing the old pods here. Let's say, so I want to update one pod. Let's say I am running a service here. The application I am running. Okay. So you want to update one version. Okay. So here you will be replacing old pod with new pods with zero downtime. Okay. So let me take the pen here. Okay. So I have Nginx. Okay. Let's say I have Nginx version 1.01. Okay. So which is running 4 instance here. Okay. So I want to upgrade it to 2.03 because there are lot of enhancement. So I want to run my website on this. Okay. It is running on the 4 instance. Okay. So initially, so I will tell, okay, this is my initial stage. Okay. So now I want to make it like I want to update one version 2. Okay. So to version 2. Now whenever there is a downtime, if let's say this want to get restarted, okay, for some reason it want to get restarted, what it will do? So this one will get upgraded to version 2. From 1.1 to 2.3 it will get upgraded, and automatically it will accept the connections without rejecting it. Then you will have one more. So it will remove that unavailable. So it will remove one pod. Okay, I am accepting the connection here. Okay. So now it will slowly act upon all the other one. It will remove all that particular pods here. It will keep on upgrading. Okay. So earlier, before these concept, so if you want to upgrade a web server or something like that, so you have to down the entire service here. Okay, let me take this one. Okay, so you have to take down all the service, then you upgrade from version 1 to version 2. So then you restart it. After that, it will get upgraded. So with this functionality, you can just upgrade on a fly. Okay. So without impacting, you are going to upgrade. Okay. So the deployment second strategy is, so if you want to go in depth on this, so it will be creating up to max surge limit. You will have max surge limit where you will be having a 25%. Okay, it will wait for new pods to become ready. Okay, so once it is ready, this one gets ready, it will remove one pod here. Okay, I will remove one old pod, and then I am going to refresh this application to version 2. So then it will get, it will check, okay, I am ready here, then it will target this one. Okay, so then it will target the other one. Now all your pods will be running on the latest version. Okay, so this will be giving you zero downtime, without any downtime. So you will be upgrading all your pods here. So this is built-in feature. Okay, and you will have a low complexity. Okay, and you have one more is recreate. Okay, so this is for simple app, and you want to do a batch jobs, or you can tell, okay, to the customer. So you will have a downtime of nearly 2-3 minutes. So I will terminate all this and then I will execute. Let's say you want to upgrade a bank application. Like old app should not be working. So what you do, you will take a downtime. Sir, if someone is connecting, then we will have a conflict. What we will do, we will just in a flow, we will just upgrade all at once. Okay, so once the customer accepts it, so you will take that downtime, and what you do, so you terminate all the existing pods here. You will stop everything. All the connection will be exited. All the connections will break. So you will terminate all that. Then you will upgrade it, and then the new version will come. Okay. So now only if you install new version, then only it will work. Okay. So now you have one more. It is very, this one is a simple one. Okay. So there is no risk here. Okay. Whereas here you will have risk here. Okay. So what happens is, let's say, so if version 2 is correct, is not working, version 1 will be working. Okay. So once it is completely upgraded, so you will have a little conflicts there. Okay. So this it is not suitable for the production here. So if you are facing any user services, so for production, customer may not like this concept. So I don't want to do this. Instead, you go for blue and green methodology. Okay. So you have in the migration you have something called green lake and brownfield. Roy, do you know this strategy? Green lake and brownfield?
No, sir.
Okay.
No, sir.
Okay.
I only know blue green.
Huh?
But no, sir. Only know blue and no, sir. I
Blue,
only know
green
blue
and
green, but only know blue and green. This type of. I
okay.
don't.
Okay.
I don't
Okay.
listen about this.
Okay. I
Canary,
will let you know.
this type of.
Okay.
I don't.
We
I
will have
don't
something in
listen about
migration
this.
terminology. Okay. So you will have something called green lake and brownfield. Okay. Green lake means you will not have any infrastructure, existing infrastructure. You will not have anything. Okay. You will build from scratch. Okay. So that is called green lake deployment. Brownfield is you have already existing infrastructure. I have 20 servers. Okay. So now you upgrade my infrastructure. Here you will not have any infrastructure. You bring in everything and you install. There is no impact here. Okay. That is called green here. This is called brown. Okay. So I will give you that all colors also. You will have blue also here. So mostly in migration we will use this concept, greenfield or green lake or brownfield migration. Okay. Now in this strategy, blue and green, you have deployment version 2 here, green alongside blue here. Okay. So you will be upgrading one and you will be rolling back. If
Something new, something old.
yeah, okay. So you are into working on
Something new, something old.
version 1. Okay. So you will have version 1 and version 2 working parallelly. What you will do, let's say you have 80% users, okay, let's say in India, okay, 20% in Middle East, okay. So what you do, you slowly ask these users, okay, so all whoever is connecting from the morning, Indian users, you just connect them 10% here to the green environment, okay, upgraded version. So if all it is working fine, so let them switch over to green environment. Okay. If it is not working or they are facing the problem, then what we will do? Okay. So you remove this, we will roll back. So we will come back to blue one. Okay. So this is where alongside you will be having a blue deployment. So where once green is verified healthy, okay, this it is working fine, then you will switch all the services to green here. Okay. If you want to roll back, if you find any issues, then you will roll back. Okay. So this is like you want to do some production migration, then you will be using this strategy here. Okay. So where you will be instantly rolling back. So if user is not able to access anything, you will just ask to roll back the changes. He will be easily roll back. Okay. So easy verification before traffic switch. Okay. So this will require your double the resources during the transition year. Okay. Let's say you have configured this on HP servers. Okay. Now you want to move everything on Dell servers. Okay. Now you are moving it, okay, onto the green. Then you are checking, okay, if this fine. Now I will be switching entire hardware from HP to Dell. Okay. So now I am running it on Amazon AWS. Okay. I want to move out from Amazon AWS to GCP. So what I will do, I will be looking at, okay. So let's have this deployment here. I will switch it over. Let me see if that works. So once this is working, then I will be doing the transition. Okay. So you have now canary. So with weights, we will be targeting just like how I have explained you. So depends on the traffic here. Okay. So I want to check on the small percentage of the traffic to the new version. Okay. So if they are not complaining, if I am not getting any complaints, so what I do, I will ask one by one to slowly come back to the green here, green environment. Okay. So where I will be running it, the latest application or dependency or upgrade, all that I will be doing it on the canary part. Okay. Slowly you will be doing it. Then this will minimize the risk by doing a testing with real user on a small scale. So you don't have to do some testing. Let's say instead of 10% traffic, you will just put a 2% traffic, so that you will see no one is facing any issues here. If they face issues, what you are going to do, you will going to do a rollback here. Okay. So this involves very high complexity. Okay. And it will require a mesh configuration. Okay. Or you need to do a traffic splitting here. Then only it will work. Okay. So this is how you are going to deploy the strategies here. Okay. So that's it for today. Okay. So I hope you get all the other recordings also.